Greetings, students, and welcome to the 2019-2020 data summary for the ONR Junior Researchers Field Campaign. My name is Mara Oriskanen, and as many of you may recognize me, I led your in-the-field experience for data collection at Carmel River State Beach. I thought I'd start today by saying thank you for all of your efforts. It really helps that I had so many extra hands this year collecting data. I know we're all stuck inside these days, and so hopefully a few pictures of the beach will get your minds churning. So with that, I'd like to start our presentation, and I will go ahead and start with the overall welcome and say this was a junior researchers project, and for those of you who want to know more about this, you can visit our website. This was funded by the Office of Naval Research in Washington, and so this is part of a larger effort to try and engage students just like you with researchers like me in gathering data and learning what it's like to be a scientist. And so with that, I thought, let's take a look back at this season. What happened during the 2019-2020 winter? So to start off, I thought the best place to start is with some pictures. And as many of you know, we tried to get you out maybe before the river breached, but as you'll notice and remember back with that rain over Thanksgiving, the river breached so early, we didn't have the opportunity. So for all of the field trips we went to, the river was actually open. And so you can see through some of these pictures quite the contrast in where the river is, what that river mouth looks like, where the rocks are, where the sand is. And overall, what you guys helped me do was gather sand data from this beach at specific locations, which I am still looking to analyze as soon as I can get back into my lab. And you provided me also estimates of water quality during this transition from open to close in the back lagoon. And so what this tells me is it can help tell me what is going on with the dynamics going on between the river and the coastal ocean, how much the ocean is impacting the lagoon, and how much the river discharge is impacting the lagoon. And so just as a reminder, here's a little lovely top-down Google Earth plot where the parking lot is indicated at the top right with that nice big white arrow. And we had 3 field trips this year back in December, January, and March. And 2 of these groups, we could find the outlines from their walking surveys, which they went and they traced the edge of the lagoon at the time when they went out. And that's indicated by those lines that are both yellow and green. All groups managed to collect a great amount of data with respect to water quality, and so we got all sorts of measurements of temperature and salinity and dissolved oxygen throughout the lagoon. So I thought I'd show you just a little bit about what you guys collected and how that fits into what data I collect also. So between all 3 of these field trips, there were many, many sites where water quality was collected, which is great. I have a lot more of a spatial understanding of how things change within the lagoon. The first table that you see is the salinity, which what we observed was that towards the north, as you walk towards the parking lot, the water gets saltier. In contrast, when you walk to the south towards the river, the water is fresher. And this kind of makes sense if you think about that from the river perspective. Being closer to the river would mean that you have more access to fresh water. Similarly, the temperature, which was interesting, actually remained fairly consistent throughout the lagoon, which is interesting because the water depth changes a lot from place to place, and usually that affects the temperature. But this is suggesting that there's a good amount of mixing in the system that's bringing the water temperature to the same point throughout the entire system. Now, this was data that you guys collected, and how that fits in is with my long-term time series, and a time series is just a measurement like you took, but over a long period of time. And so this is where I started collecting data this fall, back in November. I put out some long-term sensors that have been out there and continue to be out there. And what I'm looking at here is 2 different colors. The blue indicates the water level. So the higher that water level is, the deeper the lagoon is. And the orange represents the temperature, which is if the temperature is higher, it means it's warmer, and if it's lower, it means it's colder. I'm showing you some examples with the green arrows of what it looks like when the river is open, and some examples of when it's closed with the purple arrows. Note at the bottom, these are the class visits, and especially for the class visit at the end of January, that was really instrumental because my sensors were brought in for cleaning for those 2 weeks while you guys came out. So thanks a bunch for that. And it was particularly interesting to note that this water level fluctuated so much. And so knowing that the temperature actually remains pretty constant over the space can help me look at how that is going to change with respect to time over a longer duration. All right, and so this is great. I am still analyzing this data. I will be trying to assess how quickly do things discharge and how quickly does the breach happen. I'm going to look at how much the tide can propagate into this back lagoon, all with the motivation for why we want to do this is for the environmental protection of this particular lagoon. And so the next steps really are looking at the sediment samples. As I mentioned, I have been locked out of my lab as you guys have been locked out of your schools. And so when I get back in, my first thing to do will be to look at how much that sand varies in size. And that I can do because you guys helped me collect all those samples, which is great. I'm going to continue these water quality samples over the summer. And I have a student who's actually using some of this data for his thesis. And I continue and will continue doing to monitor the lagoon and look at those surveys between the water's edge and the beach itself. And so a little bit of a tidbit for why I care about all of this data is that I ask myself, if I have to go down to this beach every time to look at where the river is, it's very tedious and difficult because it takes a lot of time out of my day to actually go there. So if instead I could have a camera that's mounted watching this system, and you see 2 pictures here, or 1 picture here taken from an airplane, maybe I could have a tower or something monitoring the system, and maybe I could use a computer to automatically detect where and when the breach actually is. And so you're seeing the same picture twice here on the right, and the red areas in that image correspond to the bar plot that you see on the left, which is telling you the likelihood of that particular feature being in this picture and where it is. And so based off of how that bar plot looks, the 2 different things that the computer is seeing are sandy beaches and coastal waterways. And if you look to those plots on to those photos on the right, you'll see right where those are centered actually matches up pretty well. And so you guys are helping me to verify sort of the water quality aspects for the long-term monitoring. The sediment's going to help me determine what the beach composition actually is, and all of this ties in to sort of automatic beach monitoring over flooding seasons. And so many of you had questions about what do I wonder, which is great. And so one of the questions that came up is, how long have I been studying Carmel River watershed and how did I get interested in researching it? I've been studying this since the winter of 2016, so it's only been about 4 years that I've been looking at this system. And I started looking at this system because it's really quite an interesting system with respect to how quickly the sand can move around. And so when I moved here back in 2016, I saw big giant waves washing over the entire beach. And I thought, wow, that is so cool. I want to understand how those waves are moving that sand around. And so from there, it's been an ongoing project. Another question that I've got is, what is the biggest thing that you've learned about the Carmel River watershed since you started studying it? Another good question, and I thought that it was really interesting. Something that I didn't expect was that you actually still see a tidal signature inside the lagoon, even when things are closed. So there can be no river across the lagoon, and you will still see a tide. And what that tells me is that that means there's some connection between the water through the sand on the beach that's actually helping to keep that tidal flow in and propagating that into the lagoon. Next question is, during the students' data collection, what they were asked, what they wondered about the Carmel River system. And what do I wonder about it? I really, really wonder how much sand is there that's moving around, and is that constant over time, or is that changing over time? If it's changing, can we predict how that is? Or is it simply lost to the system and we can't quantify it? And so with that, I wanted to say thank you, especially to all of you wonderful students who met me out in the field. I really appreciate your time and your attention, and I hope you learned something and had fun doing it. And with that, I'll say thanks and have a great rest of the school year.